Children, it is a continuation of the chapter Gravitation. Now let us discuss about the freely falling bodies, freely falling objects. That is about the free fall. You do one activity, take a stone and throw it upwards. What happens here? After reaching a certain height, the stone starts falling down. After reaching a certain height, the stone starts falling down. Stone reaches certain height and then it starts falling down. What is the reason for this? This is due to the gravitational force. We have learned that the earth attracts objects towards it. That is the gravitational force of the earth. Whenever objects fall towards the earth under this force alone, we say that the objects are in free fall. Whenever objects fall towards the earth under the earth's gravitational force alone, such objects are called freely falling objects and such fall is called free fall. Is there any change in the velocity of freely falling objects? While falling, there is no change in the direction of the motion of the object because it moves towards the earth. It moves towards the earth. But due to the earth's attraction, there is a change in the magnitude of the velocity. Means the speed of the object changes when it moves towards the earth. You know that if there is any change in the speed, means that is nothing but the change in the velocity. Any change in velocity involves acceleration. Whenever an object falls towards the earth, an acceleration is involved. This acceleration is due to the earth's gravitational force. This acceleration is called the acceleration due to the gravitational force of the earth. Right? Whenever objects fall towards the earth, whenever object fall towards the earth, fall towards the earth under the earth's gravitational force, under the earth's gravitational force alone, such objects are called freely falling objects. Such objects are called freely falling objects and such fall is called free fall. And such fall is called free fall. So what is free fall, or what are freely falling objects? Whenever objects fall towards the earth under the earth's gravitational force alone, such objects are called freely falling objects and such fall is called free fall. And you know that there is a change in the velocity when the object starts to fall, and when it comes near the earth, its velocity becomes maximum. So, as there is change in the velocity, you can say that there is a acceleration. This acceleration is due to the earth's gravitational force. Therefore, this acceleration is called the acceleration due to the gravitational force of the earth, or acceleration due to gravity. and its symbol is small letter g. And the SI unit of this acceleration due to gravity is also, that is ms to the power of -2. So you write, whenever an object falls towards the earth, an acceleration is involved. This acceleration is due to the earth's gravitational pull and called acceleration due to gravity. This acceleration is due to the earth's gravitational pull and it is called acceleration due to gravity. So you write that the acceleration with which an object falls towards the earth due to earth's gravitational pull is called acceleration due to gravity. Its symbol is z. So you write acceleration due to gravity. Acceleration due to gravity. The acceleration with which the acceleration with which an object falls towards the earth, an object falls towards the earth due to earth's gravitational pull, due to earth's gravitational pull is called acceleration due to gravity, is called acceleration due to gravity. Then what is the symbol of the acceleration due to gravity? Symbol of acceleration due to gravity is g. So right, this is a symbol of the acceleration due to gravity. Acceleration due to gravity is denoted by the letter small letter g. Then what is the SI unit of the acceleration due to gravity? So SI unit of acceleration due to gravity. Acceleration due to gravity, that is same as ms to the power of -2 or meter per second square. Now what is the formula to find the acceleration due to gravity? According to the second law of motion, force is the product of mass and acceleration, that is F is equals to m into a. So by using that relation and also universal law of gravitation, you can get the formula for the g. So you write, to obtain formula for g means, that is g means what? It is a notation of the acceleration due to gravity. Acceleration due to gravity. Now here, to obtain the formula for the acceleration due to gravity, we have to take the help of the second law of motion and also the law of gravitation. According to the second law of motion, force is the product of mass and acceleration. So let us take m is the mass and a is the acceleration, but instead of writing a, let us write g because it is acceleration due to gravity. So write let a equals g. Here acceleration a is g. Here acceleration is acceleration due to gravity. So we have taken a equals g. Then according to second law of motion. Second law of motion. What is that? F is equals to ma. Therefore, you can take F is equals to m into g. Why you have to take m into g? Because in the place of a, here you have to take acceleration due to gravity. Here the acceleration is acceleration due to gravity. So, in the formula, you substitute a equals g. So, you got F is equals to m into g. Consider this is the first equation. Then according to law of gravitation, according to gravitational law, Newton's law of gravitation, universal law of gravitation. So you write that F is equals to what? G m into g, m into not g, m into m by d square, by d square. That is according to law of gravitation. That is F is equals to g into m by d square. M is the mass of the earth and small letter m is the mass of the object, and d is the distance between the object and the earth. So you consider that is second. Now here both are F, in the LHS both are F, so equate these two. As LHS are equal, RHS also becomes equal. So you write from first and second. From first and second. So you write mg equals gmm by d square. Here this is F is equals to mg we have taken in the LHS, and F is equals to g into mm by d square we have taken in the RHS. Here in both equation first and second both are F equals. So we have taken, as LHS are same, RHS must be equal. So you have taken here mg is equals to g mm by d square. Then here let us cancel this m and m. Then what is remaining here? Therefore g equals g m by d square. G m by d square. Here m is the mass of the earth. M is the mass of the earth, and g is the gravitational constant, and d is the distance between the object and the earth. Distance between the object and the earth. Let an object be on or near the surface of the earth. The distance will be equal to r, the radius of the earth. Thus, for objects on or near the surface of the earth, what you have to write? G is equals to gm by r square. G is equals to gm by r square. So you write, if the object is near or on the surface of the earth. If the object is near or on the surface of the earth. Near or on the surface of the earth. Then D equals R. D equals R. R is what? That is the radius of the earth. Radius of the earth. Then the formula becomes G equals Gm by R square. G equals Gm by R square. That is the formula to find the acceleration due to gravity on the surface of the earth. You know that earth is not a perfect sphere. It is not a perfect sphere. As the radius of the earth increases from the poles to the equator, the value of G becomes greater at the poles than at the equator. For most calculation, we can take G to be more or less constant on or near the earth, but for objects far from the earth, the acceleration due to gravitational force of the earth is given by the relation G is equals to Gm by D square. We know that the value of G decreases with the height from the surface of the earth, and the value of G decreases with the depth into the crust of the earth. The value of G does not depend on the mass of the object. Therefore, let us write, therefore, the formula to find the acceleration due to gravity on the surface. Acceleration due to gravity on the surface of the earth on the surface of the earth is G equals Gm by R square. G equals Gm by R square. Here what is G? G is acceleration due to gravity. This G is gravitational constant and M is the mass of the earth. R is the radius of the earth. So you write that here G is the acceleration due to gravity. Acceleration due to gravity, and capital G is universal gravitational constant. Is the universal gravitational constant. Universal gravitational constant. M is the mass of the earth. M is the mass of the earth, and R is the radius of the earth. R is the radius of the earth. The formula to find the acceleration due to gravity on the surface of the earth is g equals small letter g equal gm, capital G, capital M by capital R square. Here g is the acceleration due to gravity and this capital G is the universal gravitational constant and capital M is the mass of the earth and R is the radius of the earth. So here you can say that the value of G decreases with the height of the object from the surface of the earth and also the value of G decreases with the depth into the crust of the earth and also the value of G does not depend on the mass of the object. So you take the value of G decreases with the height of the object from the surface of the earth. Height of the object from the surface of the earth. The value of G decreases with the depth into the depth into the crust of the earth. And the value of G does not depend on the mass of the object. Value of G does not depend on the mass of the object. Here in the formula only G is there, M is there and R square is there. So it does not depend upon the mass of the object. So you write that the earth is not a perfect sphere. The earth is not a perfect sphere. The value of G becomes greater at the poles than at the equator. As the radius of the earth increases from the poles to the equator, the value of G becomes greater at the poles than at the equator. The value of G is greater at the poles than at the equator. Then what is the value of G? So write calculation of the value of G. Write calculation of the value of G. Calculation of the value of G. So write it is small letter g because the symbol of the acceleration due to gravity is g. Then here write the formula for G. And before that, you know that, write the formula here. G is equals to Gm by R square. And you know, G value, that is constant, 6.7 into 10 power minus 11 n m square kg power minus 2. And mass of the earth is 6 into 10 power 24 kg, and radius of the earth is 6.4 into 10 power 6 meter. Then you substitute the values of the G, M and R here. G equals, the value of G, 6.7 into 10 power minus 11 n m square kg power minus 2 into m. So here you write G equals 6.7 into 10 power minus 11 n m square kg power minus 2 into m. M is 6 into 10 power 24, that divided by R, 6.4 into 10 power 6 O square, then m square it is. Then it is, this is kg because mass of the earth. Then you write equals 6.7 into 6 into 10 power minus 11 plus 24 n m square. Here you can cancel m square m square. M square you can cancel, n and kg power minus 2 kg by 6.4 into 6.4 into 10 power 6 to the 12, it becomes 12. Then G equals, so you write, you can cancel decimal point here, 6, and here also if you put 6.0, that becomes 60 by 64 into 64 into 10 power 11 minus 24 is 10 power 13, then minus 12 n kg it becomes. Then G equals 230 is a 232 is a, then 215 is a 216 is a, then 67 into 15, 15 7 is a 105, and 15 6 is a 90, 90 plus 10 105 you got, and 64 into 6, 64, 16 4 is a 64, and 16 6 is a 96, 96 plus 6 102 into 10 power 1, 10 power n kg, that is G equals, you take then 67 into 15, 67 into 15, 15 7s are 105, 10, 15 6 are 90, 90 plus 10 100, so it is 1005 into 10 to the power of 13 minus 1 is 10 by 64 into 16. 16 for the 64, 16 6 are 96 plus 6 102. So write 102 4, and you can write that here kg power minus 2 into kg, that means it becomes kg power minus 2, and here n you can write that n is equals to, that is kg ms to the power of minus 2. So write n means kg ms to the power of minus 2, kg power of minus 2. This 2 cancels here, kg power of 1 and kg power of minus 1. Then you this cancel here, you write that becomes 1005 into 10 means one extra 0 will come, that divided by 1024 into ms to the power of minus 2. Then you divide 10,050 by 1024. So then you will get, that is 9s are 9 4s are 36, 9 2s are 18 plus 3 21, and then you can write 9 here. Here 4 9s are 36, 3 carry, 9 2s are 18 plus 3 21. As here there is 0, then 1 9s are 9. Then it becomes 10 minus 6 4, and 4 minus 1 3, then 10 minus 2 8 0. Then you put this one, then you write point here, because here you have taken extra 0. Then it becomes 8s, 8 4s are 32, 8 2s are 16 plus 3, 16 plus 3 is 19, then 8 0 0 plus 1 1 and 8. Then it becomes 10 minus 2 8, then 13 minus 4, 13 minus 9 4, and 2 minus 1 1. Approximately you can take, this is 9.8 ms to the power of minus 2. 9.8 ms to the power of minus 2 is the value of acceleration due to gravity of the earth. So therefore you write, therefore the value of acceleration due to gravity, acceleration due to gravity of the earth, g equals 9.8 ms to the power of minus 2. That is the value of g, that is the average value of g. But you know that as the earth is not a perfect sphere, the value of g varies from equator to pole. So at the equator it is near about 9.7, and at the poles it is little more than 9.8. So the average value you have taken 9.8.